Okay, hi there. We're about to embark onto this adventure in factoring and can't wait to talk to you about that. But as we start this adventure, we need to learn the very first rule of factoring, the cardinal rule of factoring. Before you do anything else in factoring, what you want to do is look for something really special. You're looking for a greatest common factor in your expression. If you can find that, often the rest of the factoring becomes just a breeze. So you want to look for this every single time you try to factor something. It just often makes your life much easier. And we abbreviate this as GCF. You've probably seen that before. Okay, so when you do that, you're looking at each term and you're looking for the greatest thing that could be divided out of each term. So I'm looking here at 3x cubed and negative 6x, and I'm thinking to myself, self, what could I divide out of both of these terms? And I'm really thinking to myself, self, what is the biggest thing that I can divide out of both terms? So the technique to use is to look first at the number and go, okay, so what is a factor of both 3 and 6? These coefficients both have a factor of 3. So let's take, and we are going to identify as 3 as part of our GCF. Now, I'm looking at x cubed and x. What is the highest power of x that I can take out of both of these terms? So the answer to that question will always be the least degreed variable. So of these two, which is the least degreed variable, that would just be x. And now I have got my GCF. So that's the GCF I'm pulling out. What I need to do with that is open up a set of parentheses and divide it out of each of these pieces. So what is 3x cubed divided by 3x? What's left when I divide that out? I just have an x squared left. Keep that sign, and then I've got 6x divided by 3x. Well, that would just be 2. Now, I know that I've done this correctly if when I distribute that 3x back through, I end up where I started. So let's just try that. And you don't have to actually write this part out, but if you want to, that's fine. This is actually the answer, but let's go ahead and check it by distributing. 3x times x squared, I think that that is 3x cubed. And then 3x times negative 2, that is negative 6x. And let's compare. 3x cubed minus 6x, that is what I started with, 3x cubed minus 6x. So I know that I've done this correctly. Okay, so let's look at this next one. 5x cubed minus 20x plus 45. So let's look at every term and let's just look at the number part, the coefficient part of the 3 terms here. What is the largest thing that can be divided out of these 3 numbers? 5, negative 20, and 45. I think that would be 5. So let's put that as part of our GCF that I'm going to divide out. Now let's look at the variable piece of each of the 3 terms and decide what's the highest degree I can divide out of all 3 terms. X cubed, x, and there's no variable term over here. So there's no variable piece to that GCF. All I'm going to do is divide out the 5 from these 3 pieces. Okay, so let's take a look. When I divide that out, 5x cubed divided by 5, that leaves me with just x cubed. Negative 20x divided by 5 is negative 4x. And 45 divided by 5 is 9. And again, you could distribute the 5 through. You should end up right smack dab back where you started. Okay, this next example is a little bit different because we are going to be thinking about what is the GCF of these 2 pieces. So I'm going to look at this as a whole piece and this as a whole piece. What do you see in common? What is our greatest common factor here? Well, in this case, it's a binomial, not a monomial. Okay, so we have Do you see the 2x minus 1 is in both pieces? That is our GCF, 2x minus 1. Okay, now, if I divide the 2x minus 1 out of this piece, what do I have? I have x. And if I divide the 2x minus 1 out of this piece, I have negative 7. And that would be factored with a GCF of 2x minus 1. Okay, last example here. We have negative 14x squared plus 21x cubed minus 56x to the 4th. Let's see if we can find a common factor for our coefficients. Negative 14, positive 21, and negative 56. I think that factor would be 7. What do you think? Let's see. I'm going to change colors so you can see. 7. All right, so I have a 7 here. Now looking at your 3 variable pieces, x squared, x cubed, x fourth, what is the largest number I can take out of everything? And what did I say that was? It's the smallest degreed variable that you see. I've got x to the 4th, x cubed, and x squared. This is the one I can take out of everything. Okay, so 7x squared. Now I'm going to divide that out of each piece, and let's see what we get. If I take this negative 14x squared and then I divide out a 7x squared, I'm left with just a negative 2. If I take this 21x cubed, divide it by 7x squared, oh, would this be helpful for you to see this? The 21 over 7 becomes a 3. And the x cubed over x squared, 2 of those x's cancel and I just have a 3x. And last, if I divide this negative 56x to the 4th by 7x squared, this 56 over 7 becomes a negative 8. And x to the 4th over x squared is x squared. And there we are. Now, you could clean this up and write this polynomial here in standard form. That would probably be a good idea. And that would mean this negative 8x squared comes out front. The positive 3x stays right in the middle, and the negative 2 at the end. And so this is not, by a long shot, everything that you do in factoring, but it is a good place to start with how to factor GCF.